In this video, we will use a graphical approach to calculating complex cube roots for imaginary numbers. This is actually a follow-up to a video that I did to calculate complex cube roots in your head. That calculation was for cubic roots of real numbers. This video extends that idea for cubic roots of both negative numbers and complex numbers. My earlier video was itself intended to be a companion video to a video that a YouTube creator, blackpenredpen, did. In that video, he calculated cubic roots of real numbers using factoring. He followed that up with a video that used factoring to calculate the complex cube roots of I. So, to complete the set, here is my video that uses a graphical approach to calculating the complex cube roots of imaginary numbers. Links for all the earlier videos are in the description below. So as before, we will start with a circle on the complex plane, and let's start with the cube root of -1. Now, as before, we're going to assume that we've been given the primary root and we want to calculate the other two roots. So even though we're assuming that we've been supplied with the primary cubic root of the value, for -1 it's fairly easy to see. If you just raise -1 to powers, you can see that basically the values for -1 to a power alternate between -1 and +1. So here on the complex plane, we see the value -1. Now, of course, the difference between this negative value and a positive value is that the negative value appears on the left, whereas positive values would appear on the right. So with positive numbers, we started at 0 degrees. Here with negative numbers, we just have to recognize that we're starting at 180 degrees. We start, as we did before, with positive numbers by dividing the 360 degrees of the circle by 3, in other words, the root that we're trying to find, and we see that that's equal to 120. So we add 120 to our starting point of 180, and we get 300 degrees. And then we add another 120, and that gets us to 420 degrees, but of course we want to consider that modulo 360, which gets us 60 degrees. So to calculate our values, we now have a 60-degree triangle, and of course the sine of 60 is radical 3 over 2, and the cosine of 60 degrees is 1/2. So we apply that to our circle, and that gets us a coordinate of 1/2, radical 3 over 2i. Now we already know that the radius of our circle is 1, so we don't need to actually calculate the radius in this case. So let's go to the other point, which, as you recall, was at 300 degrees. Now we could use the sine and cosine of 300 degrees, but it's just as easy to use a 60-degree angle and remember that it's in the fourth quadrant, so we have to be careful with the sign of the result. So the sine of 60 degrees again is radical 3 over 2, and the cosine of 60 degrees is 1/2. Now we're in the fourth quadrant. Cosine is positive and sine is negative. So we use those values to find our point, which is 1/2, negative radical 3 over 2i. So those are our 3 points on our circle that represent the cubic roots of -1. And there you see our values: -1, 1/2 plus radical 3 over 2i, and 1/2 minus radical 3 over 2i. Now let's apply this same sort of approach to the cube root of I. Our circle is a unit circle, so the radius is 1. We just have to remember that we're starting at 270 degrees. Although we have been given the primary cubic root of -I, again, if you look at the powers of I, you can see that I is essentially a rotation around the circle. In other words, I to the 0 is 1, that would be 0 degrees. I to the first is I, that would be 90 degrees. I to the second is -1, which would be 180 degrees. I to the third is -I, which would be 270 degrees. And then I to the fourth actually wraps back to 0 degrees. All right, so as before, we divide 360 by the root we're looking for. That's 120 degrees. So now we go around the circle in a counterclockwise fashion. So we're starting at 270. We add 120. That gets us 390, which of course modulo 360 again is 30 degrees. So we have a 30-degree angle in the first quadrant. So now we want to calculate these values. So we have a 30-degree angle. So the sine of 30 degrees is 1/2. Cosine of 30 degrees is radical 3 over 2. And that gets us a point of radical 3 over 2 comma 1/2 I. And then we add another 120. And that gets us from 30 to 150. And so you can see the same figure as we had with either positive real numbers or negative real numbers. It's just that it's been rotated, as you see in the figure. And for the second point, we have a 30-degree triangle in the second quadrant. So we just have to remember that cosine is going to be negative. And sine of 30 degrees is 1/2. Cosine of 30 degrees is radical 3 over 2. And since cosine is negative, our point will be negative radical 3 over 2 comma 1/2 I. So those are our three cubic roots of I. Now let's do an example and apply this to a complex number. Our example here is we want the cube root of negative 16 plus 16i. And again, we've been given the primary cube root, which is equal to 2 plus 2i. So that means our first point is going to be 2 comma 2i. So we use that information to calculate the radius of the circle. In other words, we square the real part and we square the imaginary part's coefficient. We add those together and we take the square root, and that would end up being 2 radical 2. And we recognize that the angle here, which is the arcsine of 2 divided by 2, is 45 degrees. So once again, we take our 120 degrees and we add it to 45. And that gets us 165 degrees. To calculate the point, we multiply by the radius of the circle, which we calculated before as 2 radical 2, times cosine of 165. And then for our imaginary component, it's the radius 2 radical 2 times the sine of 165, which is approximately negative 2.73 comma 0.73i. Then we add 120 to 165 to get 285. And again, the calculation is radius times cosine of the angle, 2 radical 2 times cosine of 285. And the imaginary component is 2 radical 2 sine of 285i, which is approximately 0.73 comma negative 2.73i. So now we have our 3 points. And from those 3 points, we can easily construct the complex value. So the three cubic roots of negative 16 plus 16i are 2 plus 2i, negative 2.73 plus 0.73i, and 0.73 minus 2.73i. So to summarize, in order to calculate the other two cube roots, we start by using the principal cube root to calculate the radius, which is done by squaring the real part, squaring the coefficient of the imaginary part, adding those together, and taking the square root. We determine the angle of the principal cube root by taking the arctangent of the coefficient of the imaginary part divided by the real part. Using that information, we can determine the second cube root by adding the angle of the primary cube root to 120. We can then determine the second point by multiplying the radius times the cosine of the second angle for x, and multiplying the radius times the sine of the second angle for the imaginary part of that point. From there, it's easy to turn that into a complex value, and that's our second cube root, and we repeat that process for the third cube root. So in that way, you can easily determine the second and third cube roots of a complex value. All right, I hope you got something out of that. Thanks for watching.